not have to remember that every time I use a whitelist, I have to have has local property so that it's not inherited, but it's actually local to the object. Another way would again be to use safe objects. And I think now is the time to describe what would be a safe object. So a safe object would be an object that does not inherit from any prototype chain. And that can actually be achieved in this, most browsers by setting the proto property to null. So this object would actually not inherit from anything, and therefore it cannot be. Yes?
The same language change which Firefox is using to make sure that setters don't require doing object initialization is going to mean this doesn't have the effect that you think it does.
Aha.
Although you can, of course, set double underscore footer, double underscore afterwards. So you might want to check this.
Okay. Okay, good. Good to know. Thanks. Yes, so we can create, the save function in this case would create a blank object that does not inherit and recursively copy all fields of the input object to this safe object. But sometimes we need to inherit some functionality, and that might be hard yeah, that's a limitation of the save function at the moment. So what you would actually like is to inherit the actual, what is actually intended. So we have this, so that the user code cannot modify the intended behavior of the built-in functions. We've also been discussing non-declarative versus declarative policies, where, and this was suggested to us by Sergio Maffei. So where an object has, it's stateful in the sense that it will return a good thing when it's inspected and a bad thing when it's actually used. And so in this case, we look at in the whitelist if the address is in there. And when we do that, we return good.com. But when it's actually assigned, then we have reassigned the toString method to mean something different. So it will return bad.com instead. So how we deal with this problem is to define a type language so that policies can declare what properties and what types it's going to inspect, and make sure that what is actually passed to the policy is coerced to be of that type. So it will work something like this. So we have some input which contains 3 fields, X, Y, and Z. And the policy has said that we're going to inspect X and Y. And we expect X to be a string and Y to be a number. But in the actual input, we have Y that is an object of some kind, something that could be stateful and could prevent the policy from working correctly. So what we do is we copy this object and coerce the Y to be 0. And then the policy will work on it and possibly change the value of Y or do some modification. But that modification, of course, needs to be passed to the built-in. So then we merge the two, assigning the Y to the actual, to what the policy is outputting, and then passing it to the built-in. So if you'd like to read more about this, the paper is available at this address. And of course, we are here available for questions, and we'd be happy to answer. So thank you for your time. Yes?
Just to follow up on that, the creation of the empty object. So do you reckon that it is dependent on specific implementations, or is it supposed to work that way?
So I'm guessing that it could be, I mean, it could be dependent on the implementation. But as far as we've seen, it's that is how it works at the moment.
Because, did I understand correctly that Firefox will not support it in coming versions? Or
Only setting the prototype on instantiation, like in the example here. So you would have to assign the proto property afterwards. So first create the object, then. So it's not, it wouldn't prevent this, it's just, it would prevent this particular line. Yes?
Can you compare your approach to other similar approaches which use policies that are enforced in the JavaScript engine? So the JavaScript engine provides a model which can use a policy to enforce on the code. For instance, one advantage they have is even with aliases, they only protect the alert code, and they automatically protect all approaches to that
Yes.
piece of code.
So one thing is that then you would have to modify the browser. And here, this is lightweight in the sense that you don't need to modify the browser either. And apart from that, so other approaches, for example, rewrite. No rewriting is actually needed here either. So it has some benefits in that sense, even though there are some technical difficulties that needs to be overcome before you can actually make sure.
Long-term view is which approach do you see going into the future? Because it seems that even though your approach is lightweight, it might become difficult to ensure security. For instance, you depend on the fact that your script executes first.
Yes.
Is that something you can maintain in the future? Or?
Yeah, so that's a good question because I mean the browser will change. So even if it holds for the moment, it might not hold in the next version, right? So, but you could also see it as if this is well received, then you might want to. Then browser vendors would actually maybe want to support this. So make it easier to create these wrapping libraries that can. So it can go either way, I guess. Yes?
Are you concerned about, so are you trying to make it so that the wrapped code cannot detect that is being protected, or you're not concerned about discovering that you're in a sandbox?
No, we're not concerned about that. Since the wrapped code wouldn't be or shouldn't be able to break out of the sandbox, then it doesn't really matter that it knows that it's being sandboxed. No more questions? Okay, thank you.